Hey friends, we're in chapter 12:3, Algebra 1, and we're going to be multiplying rational expressions. So we're just going straight into it. Basically, multiplying rational expressions is like, in my mind, coming along with a big black marker and doing this. Zoop, 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 zoop. What am I talking about here? Basically, what I'm saying is when you multiply fractions, you remember multiplying fractions, you just multiply the numerator times the numerator and then the denominator times the denominator. Well, if we're doing that, basically, we could literally just smush these two. I'm having trouble writing here. We could smush these two fractions together to make one big fraction. And I'm literally going to do that right now. So basically, I have 5 times a times b to the third times 16 times c to the third over 8 times c squared times 15a squared b. Literally, I can do that and then have a what I call a canceling party. Just start slashing because everything is being multiplied in the numerator, everything's being multiplied in the denominator. You can literally just go ahead and cancel. So let's have some fun. All right, so I have an a up here and an a squared down here, which leaves one a. I have a c squared down here and a c cubed up here, which leaves one c up here. I have a b here and a b up here. Let me cancel those guys out. Oh, that's not a b, that's a 16. That's what happens when your handwriting's terrible. Let's try it again. I've got a b down here and three b's up here. So that's going to become b squared. I know this is looking crazy, but we'll get there. I've got a 5 here, and this 15 that's going to become a 3, and this 8, and this 16 that's going to become a 2. And look at all the carnage. Look at what I'm left with. So now I'm going to rewrite everything that I'm left with. The 5 is gone. The a is gone. So this is like 1 times 1. This is b squared, so I still have a b squared in the numerator. I also have not a 16 anymore, but a 2, and I also have a c because that's to the third power is gone. And then in the denominator, I have just a 3 left, just 3. And so this is my final answer. Let's say you don't love this method of this slash and burn party. What you could do is literally go through, you can leave the problem just as it is. You can do some cross canceling. Remember, you can cross cancel when we are dealing with multiplying fractions, the 5 and the 15. Basically, I'm doing the same thing without the rewrite. All right, and maybe that feels a little bit better to you. So we can handle this in a number of ways, but ultimately you're going to be doing a lot of canceling, and so we end up with 2b squared c, and then at the bottom we are left with 3. So we get the same idea. All right, let's go ahead and handle that over here. Let me get this extraneous stuff out of there. Come back and let's get started. So I'm going to write this larger, just makes me feel better. So I have 12xy squared, and let me smush it together, times 27m to the third power p. All of that over 45 mp squared times 40 x to the third power y. And I'm going to do the same thing. We've got a lot of numbers. Let's take care of our numbers first, right? So here I have 12 and 27, 45 and 40, and I can look for common factors. So if I think about 12 and let's say 45, or let's say 12 and 40, let's do that. 12 and 40, they both have 4 in common. So I divide both by 4 and I'm left with this. And then these guys have 9 in common. So I divide this by 9, I get 5, and I divide this by 9 and I get 3. And I look to see if I can cancel vertically. I can't cancel horizontally. That doesn't make good sense, but I can no longer cancel vertically, so I think I'm done with my numbers. So my numerical value next to all of this stuff is going to be 3 times 3, 9, 5 times 10, 50. So I've got 9 over 50, and now I need to deal with my variables. Let's go ahead and deal with m. There's one m in the denominator, and there's 3 m's up here, so that leaves 2 m's. So I've got m squared. So I've kind of dealt with my m situation. I'm crossing that out. Next, I'm going to deal with my p's. I've got 1p in the numerator and 2 in the denominator, so that leaves 1p, right, down in the denominator. And I'm done with my p's, so I'm not going to look at that anymore. The next thing I'm going to think about is perhaps my x's. So I've got x in the numerator and 3 x's in the denominator. Cancel that down. I've got x squared. in the denominator, and I'm going to get rid of those x's. I don't have to deal with those anymore. And finally, my y's. I've got one y in the denominator, 2 in the numerator, and they cancel out to give me 1y in the numerator. So my final answer is this: 9m squared times y over 50 times p times x squared. In example 2, we see that this can get a little bit more involved, but that's okay. Now, here's the thing. Remember I said last time we just smooshed everything together? I still recommend that, but do not go and try to do the distributive property. Your job is to smush it all together, but see what you still have. So I'm going to say smush it all together. Go ahead, write it down as one big ginormous fraction. Smush, smush, smushity, smush. But then factor any polynomial that you have. Now, x squared minus 2x minus 15 is really begging me to say, hey, what two numbers multiply to give me a negative 15 but add up to give me a negative 2? And that would be x minus 5 and x plus 3. And you see why I didn't want us to FOIL it, right? Or, you know, distributive property and all that stuff, because I would have just obscured the whole thing and I would not have been able to see the fact that I could simplify this thing. And look, boom, bap. Those are similar. Those are the same term in the numerator and denominator, and I can cancel them out because it's all being multiplied. And then here, I can also cancel that out. So I'm left with x over x plus 3. And I'm going to stop there. You could write the excluded roots if you wanted to. X can't be 0. Let's do it, because why not? X can't be 0, and x can also not be negative positive 5. And I'll do that. So these are the things that x can't be. We can clearly see x can't be negative 3. I can add that to the list if I wanted to as well. It's not wrong. And so again, we're going to do some smush and factoring. So I'm going to smush it all together. So the denominator, nothing to factor there. It's just a plus 1 times a plus 2. In the numerator, I'm going to factor this guy. Let me do that here so I can save myself some time. Two numbers that multiply to give me 10, yet add up to give me 7 would be positive 5 and a positive 2. So I'm left with a plus 5 times a plus 2. And then here I'm going to smush and factor. And then 3 times a plus 1. You see what I just did there? All of this is there, smushed together, entire numerator, entire denominator. Now I'm going to have a canceling party. Woohoo! Let's pull out the red pen. Boom, bat, bibbity, boo. And so now I'm left with 3 times a plus 5, with the caveat that a does not equal negative 1 or negative 2. All right? So those are my excluded values if I'm thinking about this expression. So here we're going to talk about dimensional analysis. This is something I don't remember covering. I know I've covered this in pre-algebra, but I haven't had any of you for pre-algebra, I don't think. So this might be a new way of looking at it. So this is basically changing the dimensional analysis is going to really refer to changing the units. Let's take a look at this example. In the 2000 Summer Olympics in Sydney, Australia, Maurice Greene of the United States won the gold medal for the 100-meter sprint. His winning time was 9.87 seconds. What was his speed in kilometers per hour? Round to the nearest hundredth. Okay, you saw what we did there. We started off with his time. We're told to start off with his time, 9.87 seconds, right? And he did 100 meters in that time. So his rate was 100 meters per 9.87 seconds. Okay, that's his rate. Our goal now is to change these units, meters per second, right, into kilometers per hour. So I'm going to literally write down over here, kilometers per hour is my goal. So by the time I get over here, I want to make sure I'm there. So what I do is I take each thing and I need to change it to what I'm looking for. So how do we change? You might be able to do this faster. Let's go ahead and work on seconds. I want to change seconds to hours. So the question is, how many seconds is equal to 1 hour? And with a little bit of math, you guys can figure out that 1 hour has 60 minutes, and therefore each 60 minutes has 60 seconds. 60 times 60 would be 3,600. So 3,600 seconds is equal to 1 hour. Cool so far? Okay, so now what I'm going to do is turn this into a unit. Since these are equal, when I have two things that are equal, 5 equals 5, 7 equals 7, negative 3.41 is equal to negative 3.41. Stuff that's equal, if I write that as a ratio, 5 over 5, 7 over 7, negative 3.41 over negative 3.41. All of these bad boys are equal, and they're all equal to 1. What I'm trying to point out here is this. I am going to make what I call a unit ratio or a factor. So here's the thing. I can write two things. 1 hour over 3,600 seconds is just the number 1. I'm not changing the value of my fraction if I multiply it by this unit. Also, I could write 3,600 seconds over 1 hour is the same one. It's just one unit. It's the same thing. Why am I doing that? Because I'm about to apply it here. I want to change the denominator to hours. And I'm going to do that by multiplying it by this unit. I could multiply by this, but it just would make some kind of gobbledygook, seconds squared over meter hours, and nobody wants that. My goal right now is to change my time to hours, so I'm going to do that by using this one. Remember, I want hours at the bottom, so I'm going to use this unit to do so. So watch this. 3,600 seconds over 1 hour is going to give me this. Watch. I now am going to multiply these two together. When I multiply, the seconds are going to disappear and I'm going to be left with hours, okay? But before I cancel that out, I'm feeling comfortable that by now I'm going to be at let me do it this way, meters per hour. I'm still not at my goal. By the time I multiply this, I'm at meters per hour. I want to be at kilometers per hour. And so now the question is, how do I go from meters to kilometer? So I'm going to do the same thing. I'm going to come up with another unit situation to move me from meters to hours. So let's think about this. How many meters, I said meters to hours, sorry baby, meters to kilometers. How many meters are in a kilometer? And hopefully you guys know that it's 1,000. Now, I wish that our country would get on the metric system because I think it's very beautiful and it really informs us with the base 10 because we do everything in base 10, thinking about that extra credit problem I gave y'all, the base things, right? Do that. So 1,000 meters is equal to 1 kilometer, but we're not in that system, and so you may have to go and research some of this if you don't trust me. 1,000 meters is equal to 1 kilometer, and therefore I can write that as 1,000 meters over 1 kilometer. That's really basically the number 1. Or I could look at this as 1 kilometer over 1,000 meters. And I'm going to use this gourmet 1, is what I'll call it, to go from meters per hour to kilometers per hour. And so now I need to find that out, which one is going to get me where I need to go. Remember, I want to end up with kilometers at the top, so that's why I am going to choose to use this one, right? I want kilometers at the top, not meters at the top. And so now I have 1 kilometer times 1,000 meters. Over 1,000 meters, and now I'm going to have my answer. Okay, you guys see how we did that, and now what's crossing out is these units. Seconds go away, the seconds are going to go away, and then this whole thing is going to turn to meters per hour, and then the meters will go away, and then I'm going to left with kilometers per hour. I know it looks crazy, I know, but let's do it anyway. Let's go ahead. So you can grab a calculator and do some calculations, which is what I'm going to do. So when all is said and done, after plugging all this into my calculator, this over that times this over that times this over that, literally doing that or multiplying the entire top and then dividing by each of the things at the bottom, you get 36.47 kilometers per hour. All right. I'm going to switch over to the textbook really quickly because is this our last problem? It's going to be our last problem today. So you can kind of see how they did this. They took a little bit more time going through it, but each time they did the same thing. So we started with 100 meters per 9.87 seconds, and then they changed it kilometers to meters, so they did 1 kilometer over meters, and then they did 60 seconds to 1 minute, and then they did minutes to hours to get it at the bottom. Same idea, couple of extra steps done in a different order, but the concept's the same and we get the same answer. Let me know if there's some things that I can clarify for you. I look forward to seeing you guys soon. Please have a good one. Take it easy. Bye bye.